Hello, my name is Eva Luison, and let me tell you about how we designed a digital wallet for humanitarian aid distribution. The International Committee of the Red Cross is one of the biggest NGOs in the world. One of their main missions is to bring help to people affected by situations of violence. To do so, people need to register, and the RCRC distributes goods, cash, or medication to them. However, the aid distribution process relies on pen and paper, which comes with several issues. First, using pen and paper to register people and allocate them a certain amount of cash or goods means the process is slow. People are gathered at the same place while waiting, which makes the place a suitable target for attacks. Second, the process mainly relies on humans, and mistakes are easy to make. And finally, the RCRC needs to keep track of the allocation in case of monthly distribution or transactional data in case of cash distribution, which is really not privacy preserving. To distribute aid, the RCRC has different approaches. They can do in-kind distribution and give goods and food directly to the recipients. They can do what they call a cash transfer programming and give real cash to the recipients. And finally, they can allocate a budget. To reduce the risks of the pen and paper approach, the RCRC seeks to digitize its process. The digitization of in-kind distribution has already been solved in a previous work by Wang et al. The cash transfer programming relies on a third-party provider. Thus, this work aims to digitize the allocation of a budget through creating virtual currency they control. The RCRC allocates a budget per household. Every member of the same household shares the same budget. However, several members of the same household should be able to spend this budget. Each household should be provided with several tokens to have robustness. Hence, a recipient can go to a vendor and buy whatever they need. The household budget should be updated so that if another member of the household wants to buy something else afterwards, the remaining budget is up to date. After discussing with the RCRC, we defined 4 main requirements. First, the system should avoid high-tech connectivity and use low-tech technologies. The cash distribution should be made per household with several tokens holders per household. The system should be auditable so that the RCRC can prove to external donors that they spend their money wisely. And finally, the system should be privacy preserving for the recipients, and in particular, the recipients should be indistinguishable among each other. We try to stick as much as possible to the current workflow of the RCRC. We defined 5 different parties who interact this way. The recipient goes to the registration station. A certain amount is allocated to the household, and they are provided with a smart card, which acts as a token. The recipient goes to a vendor and buy what they need using the smart card. After a certain amount of time, like once in a month for example, the vendor can show to the reclaim station all the transactions they've made and be provided with real cash. Finally, the auditor can verify the transactions made by the reclaim station, thus verifying the transactions made by the vendor at the same time. Before designing our system, we defined our threat model. The parties behave differently following what the system protects. Overall, we assume the recipients can be malicious. They might cheat when registering or transacting with vendors, but they still want to keep their privacy. The registration station, the reclaim station, and the vendor are honest with respect to the operations inherent to their roles in the system. The vendor and the reclaim station can be malicious with respect to money. For example, the vendor might collude with recipients to try to reclaim more money than what they transacted. With respect to privacy, the vendor, the registration station, the reclaim station, and auditors can behave adversely to break the user's privacy. Finally, we assume that all communication are made through authenticated communication channels. The main challenge of our system is to synchronize the cards from the same household without connectivity and protecting the recipient's privacy, while meeting our security and privacy requirements. On the security side, recipients should not be able to spend more than what they have been allocated to their household. The vendor should not be able to reclaim more than what they've sold for, and the system should be auditable. Then the system should be privacy preserving during the transaction phase, the reclaim phase, and the audit one. In particular, the recipients should be indistinguishable among each other. And because there is no connectivity between the tokens of the same household, we need to store the database containing the current budget on the vendor side, which makes this condition rather complicated. To solve these challenges, our system relies on smart cards that are assumed to be a secure element, cryptographic building blocks such as digital signatures, homomorphic commitment, authenticated encryption, and message authentication code, and an oblivious RAM to update the current budget of a household after a transaction has been made. An oblivious RAM allows a client to hide its access pattern to a database stored on an external server. And that is exactly the property we're looking for when a recipient comes to the vendor to buy goods and should update the current budget of their household without the vendor being able to see which household they belong to. We instantiate the ORAM in two different ways, naive and recursive tree-based. The naive version can be seen as we retrieve the whole database, decrypt it, and send it back after re-encrypting it. And this is something we can do because all the tokens share a common secret key. Finally, we evaluated our system to verify it is practical in humanitarian settings. We evaluated the cost per transaction of the naive and the recursive tree-based instantiations in terms of transfer data and time. We compared the time of making one transaction with both instantiations, following the number of households in the system. These numbers show that for common distribution programs of up to thousands of households, our approach is practical. The total cost of a single transaction is under 20 seconds for up to 8,000 households. For larger distribution programs, the transaction time remains under 1 minute. To conclude, we designed a new privacy-preserving humanitarian budget allocation workflow which meets the RCRC requirement and has strong advantages compared to the previous pen and paper process. And finally, we show that it is practical in humanitarian settings. Thank you for your attention and feel free to send an email if you have any questions.